Today, you and I are analyzing a Chinese megacity that looks like the year 3000, where passenger trains pierce directly through high-density residential blocks instead of bypassing them. A transit corridor bisects the building, operating seamlessly between residential floors with near-zero acoustic impact. This same metropolitan hub boasts arterial roads stacked 5 levels high in a display of radical vertical planning. These concrete highways weave through extreme topography, connecting subterranean mountain transit hubs with gravity-defying architectural superstructures. One massive complex sits anchored atop 4 sky-high towers, suspended 250 meters above the urban canopy. Standard satellite navigation fails inside this three-dimensional grid, declaring you have arrived when you are actually separated by 6 vertical stories. The extreme density of this vertical layout completely breaks conventional cartography. This is no speculative blueprint of future urbanization, but a highly populated geopolitical reality. This is Chongqing, a vital inland gateway housing a massive population of over 30 million citizens. Rejecting traditional horizontal sprawl, state planners engineered a multi-dimensional metropolis. They conquered extreme terrain by building upward, downward, and directly through mountains, rivers, and residential structures. If you find this geopolitical analysis fascinating, please support our channel with a like. Subscribing ensures you never miss our deep dives into the world's most complex infrastructural marvels. We are examining the systemic planning that allowed millions to inhabit this hyper-dense mountain enclave. This continuous, state-directed expansion shows no signs of stopping. To comprehend this engineering marvel, we must first analyze the single logistics decision that leaves global observers stunned. Consider a high-speed transit line fully integrated into residential real estate. Imagine walking down a street, tracking the sound of an approaching train. One might expect to see elevated tracks supported by standard concrete pillars, a common sight in global capitals. Instead, the layout defies all conventional rules of urban transport design. The transit line penetrates the 6th floor of a high-rise residential complex, crossing directly through the structure. Citizens inhabit the units immediately above and below this active transit channel. This integration forms the Liziba Station, a vital hub in central Chongqing. When the municipal government initiated a major rapid transit expansion, planners faced a severe geographical bottleneck that forced a radical engineering compromise. The strategic transit corridor directly intersected with an established 19-story residential tower. The housing units were fully constructed and occupied. In most global cities, this impasse presents a costly dilemma. Planners would either have to alter the route at great expense or demolish the complex, compensating hundreds of displaced residents. Both options carried high strategic costs. Rerouting reduces transit efficiency, while mass demolition triggers local resistance and high economic overhead. Chongqing's engineers bypassed these hurdles with an unprecedented co-location strategy. They integrated the rapid transit station directly into the high-rise, allowing the heavy rail line and the residential community to coexist seamlessly. Achieving this required reclaiming the 6th, 7th, and 8th floors, keeping them completely free of residents. These levels were repurposed to house the structural tracks and station platforms. The apartments above and below remained standard residential zones, sandwiching the transit hub. While severe acoustic disruption seemed inevitable, urban planners implemented advanced sound-dampening technologies to isolate the structural vibrations. Ambient noise within the apartments remains remarkably low, comparable to a standard household appliance. Furthermore, specialized structural isolation joints absorb the train's kinetic energy, completely preventing any physical vibrations from reaching the living units. Residents report total acclimatization to this industrial environment. The continuous transit flow has simply integrated into the daily routine of the local population. Much like living adjacent to a major freeway, adaptation is quick. Surprisingly, these integrated units command high demand on the local real estate market. This radical infrastructure integration has evolved into a unique selling point, turning a potential hazard into a celebrated local curiosity. Real estate developers leverage this transit novelty to attract buyers. The Liziba model illustrates the broader Chinese engineering ethos. Where other nations see geographic obstacles, Chongqing sees opportunities for aggressive infrastructural innovation. Instead of demolition or capitulation, they engineer directly through obstacles. As you and I look closer, this station is merely one node in a citywide system of extreme adaptations. The scale of their bridge network is even more staggering. To grasp this, consider that Chongqing operates over 15,000 bridges within its municipal borders. While most cities rely on 10 or 50 crossings, Chongqing maintains 15,000. This massive figure represents the highest density of bridges found in any single city globally. Crossing one daily would require over 41 years to traverse the entire network. This colossal infrastructure inventory, surpassing that of entire European nations, is dictated entirely by extreme regional geography. Chongqing commands the strategic confluence of the Yangtze and Jialing Rivers. Compounding this major aquatic barrier is a mountainous topography that forces the urban footprint over endless steep ridges. Faced with sheer cliffs and deep ravines, planners cannot deploy a standard two-dimensional grid. Traditional horizontal city layouts are physically impossible to execute across this terrain. The extreme vertical relief prevents straight transit corridors. Rather than attempting to level the mountains, Chinese engineers integrated their transport networks directly into the natural topography. They built spans across valleys, over pre-existing roads, and directly into the 20th or 30th floors of skyscrapers, aligning with roads engineered high up the mountain slopes. Standing on an upper span, one can observe 5 distinct tiers of roads stacked vertically below. Each level channels heavy logistics and civilian traffic independently, resembling a multi-layered urban-industrial complex. The Dongshumen Bridge exemplifies this multi-use design philosophy. State planners integrated a dedicated pedestrian observation deck into the structural frame, maximizing its civic utility. Beyond basic transit, these structures serve as major tourist nodes. Similarly, the record-breaking Cao Tianmen Bridge ranks among the longest steel arch spans globally. Measuring 932 meters, it bridges critical industrial zones previously isolated by the river. Nearby, the Qianshimen Bridge presents another massive engineering feat. Suspended 150 meters high, its dual-deck design optimizes land use, routing heavy rail along the upper tier and vehicular traffic directly underneath. Illuminated by night, these spans project the city's economic vitality along the riverfront. The true brilliance of this design is how seamlessly these networks integrate into the topography. Spans connect directly to mid-level skyscraper lobbies, while others merge with mountain highways. This vertical transit network eliminates geological friction, keeping the economy moving. This system is vital to the city's survival. Yet, Chongqing's underground rapid transit network presents an even greater engineering triumph. Though navigating this subterranean maze introduces unique logistical challenges. When launching a navigation app here, the interface will provide coordinates. However, following these directions blindly often leads to geographical confusion. Upon reaching the designated coordinate, you will find no sign of your target destination. In this multi-tiered layout, horizontal coordinates do not guarantee spatial alignment. Mobile navigation relies heavily on global positioning systems, which are mathematically restricted to plotting points along a two-dimensional plane. It accurately calculates latitude and longitude, but ignores vertical altitude. While sufficient for flat cities, this limited system fails entirely in Chongqing's vertical topography. Your target might sit 6 floors directly above you, prompting you and I to realize that a single coordinate can stack 4 active street levels vertically. Today, you and I are analyzing a city where vertical space is completely weaponized. Saying, "I am here" is strategically meaningless. Are we talking about the upper urban tier or the subterranean network? Last-mile logistics face an absolute nightmare in this environment. Couriers track GPS coordinates perfectly, only to realize they have arrived on an entirely different vertical plane. The target could be 5 floors above or 5 below. Tech firms had to re-engineer their mapping software, adding critical altitude data to manage this extreme topography. Operatives must master a spatial layout unlike any other urban center on Earth. Residential towers feature multiple entryways, each connecting to completely different streets at varying elevations. Walk into a lobby on the ground floor, take the elevator down, and you will emerge on the 20th floor of an adjacent tower. Standard zoning laws fail when a city operates on multiple ground levels. Mass transit infrastructure takes this spatial defiance even further. Heavy rail lines do not skirt around these massive peaks. They are engineered to punch directly through the solid bedrock. Engineers carved transit tunnels directly from solid stone. This subterranean network feeds into Hongyadong, an 11-story complex engineered to cling directly to a sheer cliff face. While appearing structurally impossible, Hongyadong deploys a hyperscaled version of traditional stilt architecture. Planners in Chongqing took ancient engineering concepts and adapted them for massive modern density. The terraced facility descends the cliffside in steps. Enter the crest, descend 11 floors of pathways and bridges, and you emerge at sea level next to a major shipping river. Looking upward reveals the staggering scale above. It challenges standard spatial logic, forcing citizens to realize that what felt like the absolute baseline was actually highly elevated. Traditional cartography fails completely under these conditions. Yet, municipal planners did not stop at ground level. They pushed their architectural ambitions straight into the sky with unprecedented designs. This brings us to Raffles City, a landmark architectural marvel. It resembles a massive, futuristic vessel anchored across the summits of 4 skyscraper columns, dominating the city skyline. This 8-tower complex features a horizontal sky bridge resting atop 4 of the columns. Known as the Crystal, this skyway stretches a massive 300 meters in length. Suspended 250 meters up, higher than a 70-story building, the structure holds complete botanical parks. Planners packed it with retail zones, dining hubs, and lush indoor gardens. An elevated swimming pool hangs over the abyss. This suspended platform features a glass observation deck, giving visitors a direct vertical view of the urban canyon hundreds of meters below. It is a dizzying vantage point where ground assets appear like microscopic dots. Under optimal weather conditions, the observation deck offers panoramic visibility stretching for miles across the regional theater. The entire metropolis unfolds below, showcasing strategic rivers cutting through high terrain. But the sky-high pool remains the most striking demonstration of this vertical engineering triumph. Swimmers are surrounded by pure open airspace. The edge of the pool drops straight into the atmosphere, generating surreal imagery that functions as a powerful digital showcase of the city. This active facility is a structural marvel. The crystal exerts thousands of tons of downward force, all of which must be distributed safely across those 4 supporting columns. State structural designers had to calculate immense environmental forces, particularly high-altitude wind shear. At 250 meters up, strong winds force these giant towers to sway slightly, like trees in a storm. System engineers designed the crystal to flex with the towers to prevent structural failure. Relying on specialized steel joints, it took years of research and testing to secure this high-altitude engineering success. This complex reflects Chongqing's aggressive municipal strategy. While conventional cities leave their skylines unutilized, this administration treats empty airspace as a blank canvas for high-density expansion. Chongqing views vacant altitude as prime real estate. By stacking entire structural layers on top of existing towers, they manufactured valuable urban space directly out of thin air. Denied standard horizontal expansion, municipal planners built directly upward, colonizing the sky. Yet, the city's ultimate achievement is its transit infrastructure, which masterfully resolves seemingly impossible transport and complex logistics challenges. Consider the Hongyadong flyover. You and I can analyze how planners took a standard highway interchange and built it for maximum spatial density. It stacks 5 tiers of asphalt into a tight spiral containing 20 separate ramps. Locally, it is deemed the planet's most complex interchange, a claim backed by logistics experts. Missing an exit here results in severe logistical delays, sending vehicles miles off course. The lanes loop continuously like a massive spring, forming a dense concrete coil from above. Surprisingly, this massive node functions with high efficiency. During peak transit hours, thousands of vehicles navigate these spiral pathways without encountering major bottlenecks or gridlock. This extreme complexity succeeds because the network is multifunctional, bridging major regional highways directly with local municipal streets simultaneously. It mitigates the steep mountain terrain while dynamically linking urban zones at vastly different heights. A single interchange connects baseline river roads to elevated streets sitting 100 meters above. Simultaneously, it processes high-volume traffic from 3 separate directions. Engineers solved this spatial puzzle by adapting the highway to natural contours rather than attempting to flatten the peaks. Global transit authorities visit Chongqing to analyze this network's operational success. They study how an apparent logistical mess maintains perfect organization through meticulous, long-term state planning. The road network respects natural geology instead of trying to bulldoze it. But the municipality's transit strategy extends far beyond mere highway systems. Planners also deployed a unique civic asset, the world's longest escalator system. Known as the Crown Escalator, this transit line spans over 100 meters, climbing a steep mountain face. It replaces grueling vertical climbs with efficient, automated transit. Demonstrating massive municipal scaling, the city did not stop at a single installation. They built dozens of these systems citywide. Many penetrate deep mountain tunnels, run parallel to waterfalls, or flank major expressways. Enclosed within climate-controlled corridors, they provide secure and efficient pedestrian movement across the city. These systems integrate seamlessly, allowing pedestrians to transfer from one lift to another. The most extreme vertical transit route coordinates 3 distinct escalator networks to maximize elevation gains. Collectively, this setup transports citizens over 300 vertical meters from the lower riverbanks straight to peak residential zones. It secures high mobility for aging demographics, transforming hostile terrain into highly accessible urban space. A grueling hike up hundreds of stone steps is replaced by a brief, automated trip. The system optimizes daily commute times and preserves human energy. This blends mass transit with dynamic urban spectacle. The visual payoff peaks at nightfall, when the entire metropolis morphs into a glowing monument to futuristic engineering. At twilight, Chongqing showcases its massive energy grid. Millions of synchronized lights activate across the metro area, turning every tower, bridge, and high-rise into a brilliant beacon of development. The 2 intersecting rivers serve as massive natural mirrors, reflecting this light show upward. It creates the illusion of an urban center floating in a vacuum, proving the power of intentional aesthetic planning. This lighting grid operates under central coordination, running nightly shows where waterfront buildings sync their displays to function as a singular, unified visual unit. Visual patterns cascade from one tower to the next, rippling smoothly down the riverbank skyline. It projects an image of total systemic connectivity, as if the buildings are sharing data. By displaying traditional art alongside modern geometry, you and I see how this grand light show projects cultural heritage and supreme municipal capability to the entire world. Overhead, orchestrated drone swarms dominate the airspace, synchronizing with state-of-the-art skyscraper lighting systems. This integration of municipal infrastructure and unmanned aerial technology projects a powerful image of technological supremacy across the entire night sky. Every evening, massive crowds gather along the river, drawn by this display of soft power. The iconic Hongyadong complex, that 11-story fortress built directly into the cliffside, transforms into a glowing monument. Illuminated by thousands of golden lights reflecting off the river, this massive structure serves as a viral landmark. Global social media exposure has transformed this strategic urban project into one of the nation's premier domestic travel hubs. This fusion of traditional heritage and cutting-edge engineering showcases a unique developmental model. Beyond the architectural marvels, the Yangtze River Cableway operates as a vital aerial transit line, suspended high above one of Asia's most critical economic waterways. Operating with a capacity of 50 passengers per cabin, the 5-minute crossing provides a strategic vantage point. Suspended over the water, observers can monitor the heavy shipping traffic below and the dense vertical expansion of the metropolis. Under the night sky, this transit line offers an almost surreal perspective of state-planned urbanization. The glowing industrial and financial hub stretches in every direction, proving how successfully this terrain has been conquered. Collectively, these factors establish Chongqing as a massive triumph of geopolitical engineering. Housing over 30 million residents in its wider municipal territory and 9 million in the urban core, its planners successfully conquered extreme mountainous terrain and major rivers that would have forced conventional developers to abandon their plans. Rather than retreating, state planners embraced these geographical obstacles to pioneer vertical urbanism. This extreme vertical development actually optimizes logistics and spatial efficiency in ways flat cities cannot match. Transit times are drastically reduced by utilizing vertical elevator shafts and multi-layered roads instead of horizontal sprawl. Maximizing population density within a compact footprint allows for highly efficient resource distribution and tight municipal coordination. Furthermore, this megacity shows no signs of slowing down, continually adding new infrastructural strata to its urban fabric. Projecting its status 10 years from now remains a challenge, but historical momentum suggests it will redefine global standards of civil engineering. If you want to continue analyzing strategic marvels like Chongqing, make sure to like this video, subscribe, and enable notifications so you never miss our next global briefing. Additional analytical reports are available on your screen right now for further viewing. This leaves us with a critical question. If Chinese planners are already deploying the cities of tomorrow, what prevents Western powers from keeping pace? Is it capital allocation or a lack of grand vision? Or does institutional inertia keep us bound to outdated development models? Share your strategic perspective in the comments below.